Welcome back, everyone, to the water panel. I'm Andrew Whitehead. I'm a president. No, professor. Yeah, president would be great, but not interested. A professor and chair of environmental toxicology. I do, we'll do introductions later. So we've got a couple lightning talks, starting off with Andre Daccache and then Helen Dahlke. And then we're going to have a panel discussion after that, following up, where there's discussion between folks and with the audience. So with that, we'd like to call up our first lightning speaker, please. Andre.
Okay. Hello, everyone. So I'll try to stick with my 5 minutes. So apologies if I will be a little bit fast. So whenever we talk about California, we always get that in our mind: good weather, agricultural landscape, and technology. But at the same time, we think about drought and extreme weather events. So California is blessed with fertile soil and with Mediterranean climate. And this making it the powerhouse, the agricultural powerhouse of the nations. If I put like a few numbers here, $51 billion in cash receipts, 400 different commodities, many of them, they are sold produced in California, and many, many others. So how we did that? Actually, we managed to do that by tapping on groundwater, and we reached catastrophic levels, and also through large water distribution systems, one of the biggest in the world. As a matter of fact, California is considered as the most hydrologically altered landmass on the planet, and that allowed us to move the water from the north to the south. So as demand continued to rise and supply dwindles, there is a need to do something. So we need to produce more or the same with less water. And how we can do that? There are three different pillars to do that. One of them is education and outreach, to create a new generation of engineers, of scientists, policymakers, or even of growers, that they are well knowledgeable about the situation to tackle the problem of water scarcity. The other thing is through research and innovation, in order to embrace technology, in order to be able to create agriculture which is resilient to climate change and to water scarcity, and finally advocating for policies in order to maintain sustainability and ensure saving of water, and Sigma is a good example for this. So a few examples of what we are currently doing is through also the support of the AES and other supporting organizations. So we are trying to map irrigated, to measure soil moisture content through cosmic rays, particularly through neutron and muon particles coming from space, or by using the satellite technology for microwave, but then trying to adapt that to put it on UAVs in order to make it adaptable and suitable for agricultural application. Also, we use different type of sensors in order to understand the plant water response and response to stress. And because we believe that technology should not be limited to as a very few privileged one of growers that they are able to afford it, we adopt the idea of more for less, which is a more technology for more growers for less dollars. And we do that by developing sensors which they are relatively low cost. And also we leverage the AI technology in order to map irrigated area from satellite imagery, and also to help stakeholders to understand different scenarios, climate change scenarios and land use change scenarios to see how that it would affect water demand, and also trying to predicting what it would be the future evapotranspiration, because that it is quite useful for irrigation management and also for water resources manager for their daily operation of just like a reservoir operation and something like that. So I guess I will stop here. I'm okay on time? Okay, good. Done? Okay. Good.
Morning, everyone. My name is Helen Dahlke. I'm a professor in integrated hydrologic sciences in the Department of Land, Air, and Water Resources. And I will be talking about recharging California's groundwater. For those of you who have lived in California a bit longer, you might have observed in the last 10 years or so, we seem to be pivoting from extreme droughts and then a dumping wet year and then back to drought. And this climate whiplash has definitely put additional strain on our surface water supply, but it has also worsened some of the long-standing groundwater issues we have in California, which is, for example, the chronic lowering of groundwater levels, loss of groundwater storage, and severe land subsidence, particularly in the southern Central Valley, as well as issues around groundwater contamination, for example, with nitrate, as shown here on the right. My lab is working on managed aquifer recharge, which is a method where we try to intentionally place water back into our groundwater system. And there are many, many forms of managed aquifer recharge that are practiced throughout the state. My lab particularly works on-farm recharge, shown here on the right, which is a form where we intentionally flood farm fields with excess water, flood water, to replenish groundwater aquifers. And this method can help with many of the issues that I'd shown on the previous slide. The big question, though, is like, how do we get buy-in from growers because we are using their land for the recharge? And this is where we work with private landowners, such as Don Cameron. He's the general manager of Terra Nova Ranch. We've worked with Don for over 10 years now, answering questions such as what crops are suitable for winter flooding, or what soil suitability we have, what aquifer materials can take a lot of recharge in. We've also worked with the Water Board to inform a streamlined permit for the diversion of flood flows to underground storage. They have, for example, adopted our recommendation to use the 90th percentile on stream flow to allow flood flow diversion in order to ensure that downstream environmental flows as well as senior water rights holders are not injured. My lab is also working with UC Cooperative Extension and the Kearney Agricultural Research and Extension Center to conduct controlled experiments on nitrate in soil and nitrate leaching. And through this research, we found, for example, that as you start applying floodwater for recharge, you're going to leach a lot of the residual soil nitrate that's in the soil before we apply water within a couple of days. But once we switch the water off and the soil is draining, the additional water can actually help produce more inorganic nitrate through mineralization, which can then help the growing season, not just from a nutrient, but also irrigation benefit. We've also studied how winter recharge is impacting nitrate leaching to groundwater. Again, through private landowner experiments, we have, for example, found that in many places we have contaminated groundwater contaminated with nitrate. And if we apply a lot of recharge water, clean source water that comes from rainfall, snowmelt, we can actually dilute these high groundwater nitrate concentrations to below the maximum contaminant level as shown here in this graph. We are also working with community partners such as self-help enterprises and Lawrence Livermore National Lab to better understand the complex landscape of contaminants in general in our groundwater, such as arsenic, uranium, or hexavalent chromium, in order to see where can targeted recharge near community wells help with improving water quality as well as groundwater reliability. And then lastly, I would like to show some decision support tools that we've developed in collaboration with Toby Eugene. soil specialist. One of our favorite tools is the SAGB, Soil Agriculture Groundwater Banking Index, which shows soils that are most suitable to convey large amounts of water into the subsurface. These areas are shown here in green. We've also developed a trafficability tool. So this one is not only applicable to winter flooding and on-farm recharge, but can help with soil management in general during the wetter winter month. And it tells growers basically how many days do they have to wait until their soil is sufficiently dried out for heavy farm machinery to go back into the orchard or into the field. Thank you very much.
We'll start off by introductions for the panel. And because the lightning talks were so lightning fast, I'm also going to take a moment to introduce our lightning speakers in a little bit more detail. So Andre, who is our first lightning talk speaker, is a professor in biological and agricultural engineering. And as you can see, he's a real expert in water resources management, irrigation engineering, and crop and climate change modeling. And then Helen Dahlke, who we just heard from, as she mentioned, is a professor in integrated hydrological sciences and land, air, water resources. And she's a hydrologist, and her group studies water above ground and below ground, and beneficial uses of water and water quality and the fate of water. So we're going to introduce our panel. I'd like to first point out something that was missing in your handouts is the makeup of the panel. Was Isaya Kisekka is actually on the panel, and he's not written down on your page, so we want to make sure that you are aware of his presence, but you're going to be aware of his presence, very, very soon. So what I'd like to do is take, maybe the first 10 minutes, maybe a couple minutes per person to share, introduce yourself, share what department you're from, or what organization you're a part of. Tell us a little bit about your work on water and particularly in California. So our participants are Luis Diaz-Garcia, Anne Todgham, Stuart Woolf, Jonathan London, and Isaya Kisekka. So off.
Hi, everyone. Good morning. My name is Luis Diaz-Garcia. I am an assistant professor in the Department of Viticulture and Enology. My work focuses on developing new grape varieties. So I don't work directly with water. I develop new varieties, rootstocks and wine grapes in particular. I have basically, three main areas: promoting and conservation of crop wild relatives. So, if you look outside the varieties we normally use in viticulture, so there are plenty of varieties, there are plenty of species that can be used for growing grapes, and most of these species and most of these varieties probably have some of the traits that we are looking for to deal with climate change, drought tolerance, disease resistance, and quality as well. So we also trying to develop breeding strategies that can help us to accelerate the development of cultivars. So breeding for perennial crops can take 20, 30 years or even more. So we are looking for ways to accelerate that process. So what else? That's pretty much it. So I'll leave it for the next.
Hi, so I'm Anne Todgham. I'm a professor and chair in the Department of Animal Science, and I am a stress physiologist of aquatic things. So I really care about water from the perspective of water quality. So our research group sort of has two sides of our research program. One is understanding sort of the conservation physiology of California's native fishes, and the other side is thinking about stress management in sustainable aquaculture of both finfish and shellfish. But at the root of all of it is really understanding what are the water quality needs of aquatic species, whether they're of conservation relevance or of aquaculture relevance, so that we can manage landscapes or manage production in a way that can provide sort of as optimal as possible the water quality needs during critical life history stages, so early developmental stages, young fishes, young larvae of oysters, all the way up to other aspects of their, sort of critical aspects of their life history, like spawning in salmon, and how do we get salmon back into the watersheds where they find the best water quality. And then on the aquaculture side, it's thinking a little bit about the fact that in these sort of more managed systems, we have to also think about climate change, and can we be selecting for species that might be better adapted to deal with sort of deteriorating water quality, or also where in the management process might we be losing important sort of resilience to change. So that sort of sums us up.
I'm Stuart Woolf. I'm the president and CEO of Woolf Farming Company. This is a family-owned business based in western Fresno County. And we grow a variety of different crops. We grow the dreaded almond. We grow pistachios, tomatoes, a whole host of things. And we have some processing facilities. We operate a tomato processing facility that makes tomato paste, and almond processing. And we actually make almond paste for almond milk. And because we're located primarily in Westlands, when you think about the state, the issues of water and what have you, where my father, when he started the business in '74, he was trying to figure out what are the optimal crops to grow and during a period of abundance where he had plenty of water. Right now, I'm trying to figure out how do I manage my family's farming operations and optimize the grounds that I'm going to be fallowing. So if the state is going to fallow about 10% of the acres under Sigma, in Westlands, we'll be fallowing closer to 40%. So this is my challenge.
Not a small challenge. I am a fan of almond products. Just want to go on the record for that. So Jonathan London, I'm a professor in the Department of Human Ecology and Program Director of Community and Regional Development. I was the founding director for the Center for Regional Change, and the executive director is here, Anna Suleiman. And I conduct research on environmental justice with a community engaged model similar to my colleague Claire Cannon, who you heard from. I've done research on air, water, pesticides, land use and transportation, and I'll be talking about water specifically today, but really I'm interested in how communities are faring in exposures to environmental contaminants, how they get access to resources to buffer those kinds of hazards, and also from a process perspective, how they're involved in decision-making and policies that affect their lives. I'll be drawing particularly from a study that my group and I did a couple of years back now on disadvantaged, unincorporated communities, those without municipal governments that are low income, particularly in the San Joaquin Valley, and are facing a wide variety of threats around drinking water quality, abundance, as well as affordability. So I'll leave it at that.
My name is Isaya Kisekka. I'm a professor in the Department of Land and Water Resources and the Department of Biological and Agriculture Engineering. I sit in both departments because I'm an engineer, I'm an agriculture engineer and hydrologist. And I also serve as the director of the UC Davis Agriculture Water Center of Excellence. My work focuses on irrigation and water management in agriculture. And in this new era, as Stuart articulated it very well, we're in a new era of limited water. So I try to work with growers to help them determine which crops to grow with limited water. I also work on management technologies that they could use to cope with both climate change and regulations around limited water, as well as minimizing the impact of using water in agriculture on the environment, on things like nitrate, contamination of groundwater, soil salinity, and so on.
Thank you. And I'm Andrew Whitehead. I'm a professor in the Environmental Toxicology Department. we do this weird mix of toxicology and stress physiology and evolutionary biology in our lab. So we're interested in dynamics of populations that unfold over longer periods of time than sort of traditional toxicologists consider. So we think about really multi-generational timescales and the population dynamics that unfold after exposures. We work with climate change stressors and pollution as sort of our main foci, and think about what are the features of the environment and what are the features of species that may enable persistence or decline in human-altered environments. So in California, we're working on delta smelt and thinking about how we can maintain the genetic fuel tank for this species to be able to compensate for future environments, as well as the environment as it exists now. And we also do work on the multi-generational effects of exposures to things that are in the news a lot, like these days, like flame retardants and other kinds of chemicals like that. So as we launch off in our panel discussion here, it's important to consider these really multiple, diverse, and tightly integrated uses of water in California, right? Indigenous groups consider water to support their cultural and spiritual ceremonial practices and to support their traditional rites. Agriculture, over a third of the country's vegetables and nearly 3/4 of the country's fruits and nuts are grown in California, and that's highly sustained through irrigation. Drinking water, right? We got closing in on 40 million people in the state. That's 40 million people to keep hydrated. And then sustainable water supplies are in rivers and lakes, and the delta is really critically important for the integrity of natural ecosystems, wild species that have a deep value of their own. And these are also as places where we recreate and where we go to center our minds and our bodies. So given these really diverse and sometimes conflicting, and maybe often conflicting demands on water, we'd like to hear from the panelists, how we see, given your lens through which you sort of view water, what are the key challenges facing the state from your perspective across the themes of ag, environment, human communities. So we'd like all the panelists to chime in. Maybe, can we start with Stuart? Is that okay?
Sure. I think you're starting with the thirstiest guy at the table.
Let me grab you some water.
Yeah. Well, so this is clearly a challenge for us, and I think as the state, if you look over time from a period of abundance, I do think the state, as it has grown and become more diverse and became more aware of environmental issues, social issues, groundwater quality, clearly we failed to make additional investments in conveyance and storage and to have more of it. And so I always liken this to having like a pitcher of water on a table with a bunch of thirsty people, and then coming along and cutting that like in half and putting more people around the table. We end up basically being in conflict. We become competitors of the water. I think this is a real challenging kind of thing. To our ranch, and more specifically, like the property that I'm managing, I have to say I'm a little bit energized by the challenge. I've been surrounded by people in Westlands that have pointed the finger at government, that have been very angry to lose their family's property, and all these challenges. But I think instead of kind of complaining about it and entering into lawsuits and what have you, we just took a step back and figured, okay, what do we do with like 40% of our land? How do we generate income with less water? And I know there are a lot more smart people in here than me, but we just figured out like, okay, we're going to convert some of it over to solar, going to generate some income. We're actually taking some of our land. We're in an area within Westlands where we can actually do groundwater banking and recharge. So we have 10 separate basins to do that. We're looking at our cropping patterns to figure out what crops can we put water on when. We're also looking at alternative crops. The last time I was in this room was for an agave symposium, and it was packed. And I think I think there's kind of this growing buzz about growing a crop that, in our case, we're putting 2.5 inches of water on it to grow a crop that, quite frankly, I'm pretty excited about. I happen to like tequila and mezcal. I haven't had any yet today, but I will. And, honestly, I look at it and I think for parts of the West Side and these regions that are really at the tip of the spear when it comes to water curtailments and what have you, I really do envision kind of like a Napa Valley of like distilled agave spirits in a region that is so deficient of water. So anyway, these are the kind of things that at least I'm super excited about. I would just say also, I think the state, there could be a role for the state to do a much better job of figuring out the regions where we can actually recharge and the crops that are grown there and the soil types, like the maps that Helen had shown, that where we could actually optimize and figure out how to capture and put in the ground the water when it's available. Because I think it's kind of a crying shame that when we do get the big storm events, we seemingly don't have a plan to utilize those waters and store it. And I'm not talking about new storage. I'm just talking about like gathering more information to know where we could put it, when. And I know it's a complex thing with water rights and land use and everything, but I think we are falling behind and not figuring out a great program to capture the water we need when it's available. Anyway.
That's a really good transition maybe to ask Isaya next. As you think about optimizing irrigation and water management from your perspective, what are the key challenges facing California?
I think the key challenge in facing water management in agriculture in California is climate change that manifests itself into multi-year droughts punctuated with wet years. And the challenge with that, as Stuart mentioned, is our water demand is kind of offset from from the supply time. We use our water mostly in the summer and we get most of it in the winter months. So without storage, it becomes very difficult to manage. And in addition to climate change is regulation. So SGMA, or the Sustainable Groundwater Management Act, passed in 2014 by the state of California, is changing the landscape of agriculture in the state. For example, in Westlands, where Stuart is, they have water allocation limits. In some areas, their water allocation is only 14 inches per acre. That's not enough to grow most crops. And so the question is, if you have less water allocation than you need to grow a crop, what do you do? So you concentrate that water on a few acres and grow a crop very well instead of spreading it across many acres, as well as adopting technology like micro-irrigation that could help growers cope with some of these challenges. The challenge is we're already very efficient, that efficiencies alone cannot get us out of these challenges of water.
Jonathan, would you like to go next through the lens of human ecology, big challenges?
Yeah, absolutely. Great conversation so far. So some people may know back in 2012, California took the lead in recognizing a human right to water. So thinking about water not just as a commodity and not even just as a government service, but just something by virtue of being human, we have the right to. And that was recognizing the right for safe and abundant, that is accessible, as well as affordable water. And unfortunately, we're human right violators by that definition. California is not providing adequate water supplies or safety or affordability. In fact, over 1 million Californians don't have access to that level of drinking water. Those are particularly focused in smaller rural communities inhabited many times by farm workers, as well as in urban areas inhabited by other people of color and on tribal lands. Our study found in the Central Valley that 1/4 of all of the water systems were providing unsafe drinking water. And these are polluted by many of the things that Helen mentioned, nitrates, much from agriculture, fertilizer, and manure runoff, things like perchlorate from industrial sources, pesticides, uranium, and as well as arsenic, which are naturally occurring. But if a community doesn't have adequate water treatment, then it's taking up that arsenic into the water supply. Many communities that are disadvantaged and unincorporated don't have water systems at all. So they're getting their water supplies from domestic wells. Because they're low income, those are generally untreated. So they are just drinking raw water from the aquifers, which are polluted for the reasons we're saying. And because of climate change and competition for groundwater, which hasn't been regulated in California until Sigma, as Isaiah was mentioned, a lot of these small communities with very shallow wells are being out-competed for water. So their wells are literally going dry, and they have to buy bottled water, which is very expensive, even though they're already paying very, very high rates, much larger rates than probably all of us in the room compared to their level of income. They're having to buy replacement water and bottled water, which is not as well regulated, as well as just hard to get to if you don't have a car, for example. How are you going to get a big bottle of water home? So these are, as they say, violations of those human rights. And fortunately, there's a number of different policies. We'll get to that in a moment. But I'll just say the good news is, for California, there are a lot of these different kinds of policies that are about infrastructure investment, about political reorganization of jurisdictions, but even those have challenges in being able to be implemented, and we can get to that as well.
And you see the world through the lens of non-human creatures, looking out through the eyeballs of fish. What are the challenges that you perceive?
Yeah, so I was thinking about what Andre put on his slide, that this is the most hydrologically altered landmass on the planet. And so I think about how do we support and manage wildlife that need this landscape to be as wild as possible to be able to do what they need to do. And then I was thinking about what Stuart said with the pitcher. So as a person who loves fishes and studies fishes, like imagine that pitcher is also hooked up to an aquarium. And you are supporting like a whole, and it could be anything, right? I think about it from the aquarium perspective, and I would never say that fishes are more important than people drinking water or people having enough water to grow the food that they need to grow for California and the world. And so, I mean, I guess I would say I think it's a fascinating landscape to be an academic in, where we have all of these perspectives that we bring together, where we bring as many people to the table as possible to think about these sort of critical water issues. But from the fish's perspective, so we'll talk about California native fishes. That's what I spend a lot of time thinking about here in California. So these would be our salmon, like Chinook salmon, our steelhead trout. We've got sturgeon and smelt who like to feature prominently in the news. And they can't have an endless supply of water. So when do they need the water of the highest quality, right? And I think working with folks at California Fish and Wildlife and at NOAA and the U.S. Geological Survey, we can understand what levers we have that can modify how much water is delivered to the natural system versus how much water is diverted to municipal and farm production. And so as a physiologist, I can help provide insight into what are the most vulnerable stages of at least the fish, from the fish's perspective. So how do we do that? If we have a massive decline of species like smelt, if we want to reintroduce them after we've thought about the genetics, which is something that Andrew's group is doing, where do we put them? Where's the best place? What's the most, where do we have some restored spaces within the San Francisco Bay Delta area to put the fishes back? And then I guess the last thing would be, we are also the most dammed system in terms of damming our water to regulate water. And we've excluded our fishes from these really prime habitats that are up above the dams. So how do we get fishes back there? And so lots of folks have probably heard about the Klamath Dam removal that's happening right now. But there are similar sort of thoughts about what's going on in California too. And that again, now we're bringing in engineers, we're bringing in indigenous communities, we're bringing in water districts to think about, and farmers. How do we do that? So the greatest challenge I see on the sort of natural side is how do we balance the needs of the sort of anthropogenic needs that we have on a system with the natural needs of our wildlife, all while sitting in a shifting baseline because of climate change.
Follow on that, given, again, through the lens of agriculture and some of the most important crops that California is famous for.
I was kind of surprised when I was invited by Melissa to talk about this. I'm a geneticist. I don't know that much about water or policies. I work with grapes. And so, we as breeders, we are not solving the problem directly. It's more like an indirect solution. We are making the system more resilient to the problem, which is climate change and drought and other problems. So, we have been talking about climate change, reducing the availability of water, reducing the snowpack in the Sierra, making, increasing the variability of weather. We have, like 5 inches of precipitation in the Fresno area, 3 years ago, and then 10, and then 15 last year. So, highly inter-annual variability. So it's becoming more and more challenging to grow grapes. So, growers now have to rely more on groundwater, increases salinity, in some areas. So it's becoming more and more difficult. It's expensive. It has an impact for the environment. The accumulation of nitrates and other elements. So I'll just look at my notes here just to make sure I'm following the idea. So, in the case of viticulture, grapes are probably one of the most important economic drivers in California. So we have probably just 3 solutions to deal with this. Well, maybe 4. We can grow agaves now instead of grapes. But yeah, so, it's predicted that by the end of the century, many of the viticultural regions here in California, you can think about Napa and these very important places, they are going to be unsuitable to grow grapes if we don't do something. So one solution is just we can pack and move northern parts of the country. So this is a very drastic solution, and a lot of people are not going to be happy with this, so probably want to avoid that. So the other solution is we can improve management practices, improve the way we irrigate, make more efficient decisions to conserve water. We can change the trellising systems, canopy management, all of these techniques that viticulture is used. And we have been doing that for 50 years. Temperatures have been increasing for the last 60, 70 years, and yield has been stable, quality has been good. The problem is what's going to happen in the future. Are these improvements we are making to our systems are going to be enough to deal with future conditions? So that's kind of the tricky question we have to answer. And the third solution, which is probably what I am focusing on, is just genetics and breeding. So developing more efficient, water-efficient crops, in this case, grapes, that can help us to keep productivity, keep quality. So we all like to drink Cabernet Sauvignon from Napa. Hopefully we can do the same for decades. What if we cannot do that anymore in the future? So we'll have to look outside to other varieties that are better adapted to those conditions. And as I said at the beginning, the problem with breeding perennials like grapes is that it takes 20, 30, 40 years to develop. And so far, most of the efforts in grape breeding have been for a very specific traits like disease resistance or aroma, things like that are a little bit easier to develop, to breed, because it's just one gene. For drought tolerance, for example, there are hundreds or thousands of genes, and it's going to be very difficult to improve those characteristics. It's going to take many years of development, so we better start now.
Yeah, I think what you give voice to quite nicely is sort of two general categories of solutions. One is sort of mitigation-oriented solutions where you're, through technologies or innovative social policies, you're trying to mitigate impact. And then another sort of class of solutions is trying to build more resilient systems themselves in the first place. I know as we're talking about solutions and how the panelists sort of perceive opportunities for solutions or solutions that they're implementing now through their research. I know, Anne, you sort of work in both of these, building more resilient systems as well as building partnerships to sort of mitigate impacts. Do you want to speak about some of those strategies that you see for mitigating impacts?
Yeah, I mean, I think one of the important pieces is we always need to have the right people at the table making decisions. And we need to think about who are all the folks that are going to be impacted or are impacted by the current concern that we have. And I think when we bring those partnerships together, we come up with more innovative solutions. And so our group, along with a number of others at UC Davis in the Wildlife Department, at the Center for Watershed Sciences, are partnering with Indigenous communities in thinking about salmon conservation. So I'm working with the Winnemem-Wintu tribe and Chief Sisk, and they're the Winnemem-Wintu are kind of up in the Redding area. And they are a font of knowledge that we have excluded from salmon conservation largely up until now. And salmon are in dire straits in California. I mean, I think, I can't remember what the projections are, but something like in the year 2070, we are going to have a total of 7 species of salmon left, and none of them will be in the Central Valley if we don't do something. And so we need to be bringing all the smart people to the table, and that includes folks who we haven't talked to before, but actually have probably a larger vested interest in salmon recovery than us being able to go out and fish salmon, right? So Chief Sisk, who we work with, feels like it's not just healthy salmon, we need a healthy river, and that will lead to a healthy community. And she's quite upfront. If we don't have salmon, we don't have the Winnemem-Wintu. And so I think what's been really great about our partnership, and what I think Chata talked a little bit about, is not going in and telling people what we think they need to think about. It's really this co-production of knowledge and really listening to what are the needs, and how, as UC Davis scientists, how can we use our skill set to help them reach the need? And so we've come up with a really innovative solution that Chief Sisk came up with about how to reintroduce salmon to the McCloud River. So the McCloud River is above Redding. The Shasta Dam has basically blocked the salmon migration from the Sacramento River up into the McCloud River. And so through co-management and co-stewardship agreements that she has with both Cal Fish and Wildlife and NOAA, salmon are now being brought back up over the dam. They're being flown in and then driven back down. So we need to work on that piece. But she didn't want to use the traditional system, the hatchery system that we have in all of our hatcheries. We've got some phenomenal hatcheries here that are doing their best in California to keep our salmon alive. It's just it's sort of a losing battle. She didn't want that to raise the salmon she wants them to keep their wildness. So she developed this system that basically, she developed it and we built it here in Davis, and it's now along the McCloud River, and we had the first successful reintroduction or rematriation of salmon this past summer, and this coming summer we're doing it again. And I just want to highlight the importance of our state and federal agency partners as well. Cal Fish and Wildlife realized that Chief Sisk's system is considerably better than the one that they're using, so this coming year they are going to use Chief Sisk's system. And so I just think that these types of partnerships are important for creating these innovative solutions. And this is just one part of a very complex picture that also actually involves wetlands, and thinking about how do we bring in the water districts, how do we bring in the farmers, because we are going to have to figure out some sort of a volitional passage that takes our fish from one side of the dam up into the McCloud and then back, because this helicopter truck situation isn't going to keep them wild.
And so that's a nice introduction into sort of an example of community engagement and stakeholder engagement. Jonathan, you do a lot of work, sort of community engaged work through the lens of environmental justice. How do you see some of the key opportunities for solutions?
Yeah, thanks. Well, first, I just wanted to really appreciate, Ann, your work with Windman Win2 and connecting to Dean Dillard's great invocation of the land acknowledgement, and just note here, celebrating the land grant system, to really recognize whose land was granted to whom. And it wasn't our land. It wasn't the federal government's land to give away, nor the states to give to UC Davis. It was, of course, indigenous land. So we're slowly getting around to a reparations perspective. That said, I think there are some really interesting solutions being developed, and a lot of those really are driven by community groups, so groups like Community Water Center, which is co-founded by Laurel Firestone. Laurel is now a board member of the State Water Quality Control Board and is bringing that kind of environmental justice values up into the state level. A lot of the state appointees as well as staff have a strong environmental justice orientation. There are whole new, most state agencies now have an environmental justice and tribal affairs program that's new, really, just in the last decade. So there's some really positive things there. Partly informed by the study that I was mentioning on water justice and disadvantaged unincorporated communities. In 2019, Senator Monning led an effort to pass a bill called the Safe and Affordable Fund for Equity and Resilience, or SAFER. And so that was really is intended to address that million plus people who don't have access to safe and affordable drinking water, and is making $1.3 million over 10 years, some from the Greenhouse Gas Reduction Fund that Ranjiter talked about earlier, making that available to fund disadvantaged communities both in urban and rural areas around the state. So that's a massive investment and a massive success that really shows the power of the community sector, the water justice sector, working with the legislature, working with the university, and with the state agencies. There's a number of other solutions that are necessary to be able to address those historical inequities. So one is really a political issue. And so a lot of these disadvantaged communities are actually quite close to functioning water systems who could supply this kind of clean drinking water. But for a variety of different historical reasons, they've been excluded from the boundaries of the cities. Some of those cities grow kind of like amoebas, and you have the disadvantaged community being surrounded by the city, but not actually provided services by the city, or cities that have a disadvantaged community a quarter mile or a mile away that won't extend their services or won't consolidate with those water systems. In some cases, the state water boards has taken regulatory action to compel cities to do that. In other cases, cities are doing that voluntarily, taking advantage of some really important funding from state government. So there's a lot of important innovations that have happened that have really been identified by community organizations and in many cases run by community organizations. I think there's a lot more to be done. There's looking at beyond drinking water, looking at issues of wastewater and sanitation that is really important. There's tracking things like the benefits of Sigma, as has been mentioned a couple times, the actual implementation of SAFER. There's been some concerns raised about how well and how quickly those funds are getting out there to the most disadvantaged communities, as well as being able to track the changes in consolidation or service extension from functioning water systems to those that don't have access to that clean and affordable drinking water. So there's a lot more to go, but the great news is there really is some strong foundation, policy-wise, community-wise, research-wise, to build on.
Jonathan, I'll ask you to talk a little bit more maybe to this additional topic of like where do you see some of the impacts of some of the research or of you and your colleagues on policy as it has to do with water and communities, disadvantaged communities maybe in particular?
Yeah, so I would say one of the key successes that we had, which we're most proud about, is the passage of the Safer Water Investment Bill back in 2019. So our research was done, invited by a lot of those water justice organizations, as well as a number of the philanthropies that support them, because they were really trying to ramp up their campaign to build political will to support the development of that policy. And they drew on our research that for the first time mapped out where those disadvantaged unincorporated communities were, as well as the conditions that they were living under in terms of access to any kind of water system, access to a water system providing safe drinking water. So we created a whole new mapping system that identified those communities and linked that to water quality data, which the state never had before. So it was really able to make a very compelling case, not just sort of anecdotally, community by community, that one doesn't have drinking water or doesn't have drinking water over here, but really to look at it systemically and to be able to see like the broader historical patterns that have led to those kinds of inequities, as well as the potential for change. And one of the things that we were most pleased about, really excited to see and not expecting, was in fact when we mapped the proximity of the disadvantaged communities to functioning water systems providing safe drinking water, we found that they were really close. So 2/3 live of these areas without clean drinking water live within a mile of a functioning system, and actually about 45% live even within 500 meters, so almost a stone's throw. So it's not really just a physical, technological fix, it's really political will. And so our research was able to be used by the water justice groups to really demonstrate, look, this really is possible. We really can make a difference. We do need investment. We do need political support from the state, but the research really has shown us there are feasible solutions. And then since that point, the water justice groups have used the research on a variety of other bills to try to move towards greater consolidation of drinking water systems, again, so the areas that are not providing drinking water can get access to that from nearby functioning systems. So the key formula there are really good data, creating clear visualization systems, and then very intentional and ongoing partnerships between the researchers and the water justice groups.
Stuart gave voice to a lot of the water management challenges of growers, and Isaya, you do a lot of work in thinking about sustainable groundwater and agricultural irrigation and technological solutions to that. So I wonder if you could speak a little bit about how your work is contributing solutions, and perhaps maybe even at the end how it might have affected policy or informed policy.
Yeah, I have a multi-state project. And the title of it is Micro-Irrigation as a Sustainable Technology for Crop Intensification. And we've chosen to focus on micro-irrigation in our AES experiments because we think it will have immediate impact to the growers. And I'd like to highlight one example for a grower that I was working with between Davis and Woodland. She farms about 500 acres of almonds. And I went to her and I said, why don't we turn your irrigation system into an autonomous irrigation system? You can think of an autonomous irrigation system as a self-driving car. It turns itself on, it remembers what it has done, it knows when and how to irrigate. But she told me that's not my immediate problem. My immediate problem is coyotes are chewing my irrigation lines, and I'm spending thousands of dollars to hire people to fix them. And that really told me that it's not about what we imagine when we sit in our offices as labs, as solutions, but we need to go to growers to understand their problems, and we can co-create solutions that have impact. And in terms of our research informing policy, I think I'd like to highlight 3 examples. One, my research did not inform creation of Sigma, but it is informing how Sigma is being implemented. A lot of groundwater sustainability agencies, as my colleague Helen showed, are using 2 approaches to achieve sustainability. The state has given them up to 2040 or 2042, depending on how depleted their aquifers are. So they can bring in extra water through recharge, or they can implement something called demand management, where they impose restrictions. And that's where our work is having impact, because a lot of them have chosen to use satellite monitoring as a way to monitor if a grower X is using more water than they allocated them. The challenge with that is there's a lot of uncertainty in these remote sensing estimates. And so we have created solutions where we are combining ground measurements and remote sensing to reduce this uncertainty, to improve confidence between the people that are regulated, the growers, and the water managers that are tasked with achieving sustainability. The second example is our work has informed the State Water Board regulations on nitrogen. There's a regulation called the Irrigated Lands Regulatory Program, and every grower in California has to comply with nitrogen discharge. So they can comply as an individual grower, or they can go in as a nitrogen management zone. And the State Water Board has adopted models, and these are hydrologic and crop growth models that they use to assess if a certain township is doing well in terms of management practices to protect groundwater, because putting wells everywhere was practically not feasible. So we are creating data to test if these models are actually accurate. Because what you put in the model, garbage in, garbage out. So we're trying to improve that. The last example in terms of informing policy is I've worked with CDFA on the tools that they have a program called the State Water and Energy Efficiency Program called SWEEP, where farmers can apply for up to $100,000 to buy irrigation equipment to reduce water use and greenhouse gas emissions. So they have tools that they use to demonstrate how they will achieve these outcomes. And I worked with CDFA to improve these tools.
Thank you. So before we open it up to questions from the audience, maybe can I ask Stuart, as you are grappling with a lot of challenges as a grower, and as your eyes are on the horizon into the future, are there partnerships that have been important for you, or partnerships that may be important for you in the future, and coming up with some solutions as we think about sustainable agriculture in the future?
Yeah, no, I think, okay, I'm going to be 65 in about a week. So I've been at this for a while and have, throughout my career tried to establish relationships and what have you. And some clearly have been a lot more fruitful than others. But, I have to say, and please don't take this the wrong way, but I've given up on hoping that we're going to figure out how to take care of the Delta and improve the lot of fish and wildlife, and which, I absolutely would love to see success there, because if we had success, I'd likely be getting a little more water. But over my lifetime, we've made very little progress there, and it should be a disappointment. So we've got to continue to study, but I don't know that I'm going to be trying to collaborate on efforts where we just haven't had much traction. With the university, actually, my wife and I have donated some money for agave research, because I do think it's I think it's about adaptation, and if we don't have enough water, can we figure out are there better crops for us to be growing in some of these arid regions? And a crop like this that's relatively, there are agave all over California, but it hasn't been grown commercially. So we have no products that we can use on agave. There's nothing registered. And everything that we use, you have to get a permit and what have you. So it's challenging, and it's a small crop. And so we need somebody like the university to help us build the case that, instead of us trying to fight the battle for more water, help us figure out like crops that are better suited. And so this is, I think, I look forward to that collaboration. I just, in thinking about this, there's just a couple things top of mind that I just wanted to mention. One, throughout the state, we have a system of water rights and what have you. And I'm always struck that relative to energy or air quality or what have you, we have a lot of regulatory focus on, applying the best available technology and mandated to use the best, cleanest boilers or whatever it is. As it relates to water, we really don't do that per se. And so our ranch is 100% under drip or micro sprinklers with sensors because we've been at kind of the tip of the spear when it comes to water reductions. But I look at friends of mine in the farming community that have stronger water rights, have greater access, and they haven't been, I don't want to say forced into using some of those same tools, but it just makes me wonder, there's this concept of beneficial use. And if you have access to water, should you be allowed to squander water? And, I don't think so. I think you've got to use the best available control technology. And anyway, so that's kind of one issue that I think about generally. And then the other one, most recently when I've been approached by hedge fund managers who have been buying land to sell me water, I'm all for free market economics and what have you, but there comes a time where you think, really should somebody with deep pockets be able to profiteer off of the policies in California and the water struggles and what have you? It doesn't feel right to me. With that said, I'm an advocate for water markets and allowing it to flow to its highest and most productive use and to meet the environmental needs and social needs and everything. But I think there's some policy issues here that we got to be aware of that are before us.
Thank you, Stuart, for really tying together the social policy, the ecological challenges, the grower challenges. It's complex. So given that complexity, we want to have a lot of opportunity for back and forth with the audience. And I'd like to remind folks that Helen and Andre are also available to answer questions for their work and for Lightning Talk. And please, Helen and Andre, feel free to jump in if there's a question that you have something to say for. Thank you. So let's start.
Thank you very much. Very interesting. I have a question that concerns probably everybody that drinks wine, and this goes to Dr. Diaz-Garcia. I'd like to know how the fires that we've had and air pollution has affected the grapes, particularly in 2022 when we had the Napa fire. I go out and I look at the wine bottles and I say, I don't know, 2022 may not be a good year. So I'm just wondering if the air pollution also affects other crops and if studies have been done, but particularly in the grapes.
I don't know about other crops, but probably there is also an impact. For grapes, it has been, very dramatic. There is a lot of research in our department. Anita Oberholster is evaluating, for example, different methodologies to remove this smoky aroma of the wines. She's conducting control experiments with these big greenhouses, putting smoke inside at different times and seeing the effect of this on the grapes. This is pretty new. And I think she has a lot of very interesting results. I'm not an expert on that area in particular, but yeah, it's really important.
An opportunity to highlight that we're having posters at lunch, and I believe one of the posters is on that very topic. So be sure to check out all the posters at lunch. But back to Q&A.
There's also some real cool research on campus that's looking at how wildfire ash, as it settles into the rivers, is affecting the respiratory abilities of a lot of the creatures in those streams as well. So wildfire has many tendrils of effect. Thank you for that question. Stuart, did you have other colleagues and growers that really saw impacts on yield or quality from the wildfires?
No, I have friends in that suffered from smoke taint and what have you from their grapes. But I was going to say you should just drink mezcal and be comfortable with a smoky. Okay, this will just sound totally like I'm a fruitcake. But when we had some of those days where it just filled up with smog or the smoke. For our tomato operations, when it was crazy hot, it actually provided almost like shading. The air was terrible, but we actually kind of benefited from not losing fruit out in the field from sun scald and everything. I know it sounds crazy, but it was much better without the fires.
Hi, thanks so much. I'm also a supporter of agave, and I'm just curious if you could come up with some other names of top 10 crops that are used for drought tolerance. I've worked with moringa in the Central Valley, and just wondering if you have other ideas, hibiscus and other potential solutions that hopefully are food more than cannabis and wine and tequila and intoxicants.
So I've been involved with sustainable conservation and an organization that's been looking at various heirloom grains and all these different things that require less water. But I kind of came to the conclusion I actually need to generate some income and a lot of these crops, the reason they're not grown here is because they don't. They're not sustainable economically, and so that's been the challenge. I know there's the Waiuli or whatever to make natural rubber. I think the town of Firestone in Arizona had anyway, but I'm just sticking with agave right now, one thing at a time. But if I can think of others, or I'm aware of others, but none that hold probably as much potential. Wait, and you can make sugar out of it.
I'm curious about I see a tendency to grow certain crops in wet years and not grow them in drier years. And that gives us flexibility to maintain things like urban water supply. And we're seeing, as we've heard, increasing pressure through climate change, reduced snowpack, water quality issues, and so on, increased wildfires and problems with toxicants in water because of that. So is sort of expansion of what we grow when and just being opportunistic and having the flexibility to do that, is that a major part of the answer, or do we need other solutions to address our water crisis?
Yeah, I mean, many of the crops we grow are perennial crops, so there is not that much room to change.
I think it's a great question, and what we've kind of figured out is worst case scenario, if we have zero surface water and Sigma's fully implemented, how many crops with hard demand, permanent crops, can we actually sustain on the ranch? So we've already built that kind of into our models. The thing that I always think about I think there's something like 75,000 farmers in California. And how many of these farmers are smaller, that are not diversified, that may have a 20-acre block of vineyards or almonds or whatever? I don't know what they do. I think we are long-term going to squeeze those smaller guys out. There's just And this isn't because the big guys are getting bigger. The big guys will get bigger because they're the ones that ultimately will pay the others their exit. You know, for me, that's a terrible, terrible challenge we have in the state as we move forward. But, you know, I think it's easier to do for the larger players. It's tougher for the smaller ones.
That
You actually
feeds
have
in-
to have scale at some level.
Andrew, can I jump in briefly here? That's actually an excellent question, and the state is actually trying to make some effort in that regard as part of something called multi-land use repurposing program. They are flexible options where growers could get some money to grow low water intensive crops in wet years, for example.
So as we think about, you know, there's that aspect of, you know, wet year, dry year kind of pivots that can be made. There was mention early on about storage, right? And the storage, you know, there's dam storage, but really where all the storage is underground. Are we anywhere close to having the technology, the political will, the ability to be able to improve our underground storage in wet years?
I'd like to defer that question to my colleague, Helen.
Yeah, there are several efforts underway. So the state has just completed a so-called airborne electromagnetic survey. They invested $20 million into this one. It was a little airplane that flew an antenna around. And from that geophysical data, we have, for example, a better understanding of where are coarse materials in the subsurface, sands and gravels, which we would prefer as recharge locations. As Isaya was mentioning, many groundwater sustainability agencies are looking towards recharge. They all have about 50% of the demand that they need to reduce. They think they can capture with recharge, or like address with recharge. I see a growing competition between local agencies about water. So the question is, even, you know, if we have these big flood peaks and there is lots of water in those flood peaks and we can't divert all of that water into underground storage, it's physically not feasible. But we already see competition about this water, and there is language like, you know, the upstream guys are saying, we're not going to let any drop out of our jurisdiction. And I'm always laughing at this because I know when it's flooding, it's flooding and you won't be able to hold that water. It will go downstream, but there are, you know, environmental needs. So there's efforts underway, for example, to integrate the water rights system with environmental flow requirements. For example, the Delta has certain flow requirements between February and June to aid fish migration, the spring salmon run, for example. Traditionally, we have released water for that purpose, and we still have to do that in future years. But just to release water, you know, it's not making the fish happy. They need certain flows. They need certain flood peaks. They need certain durations of flows. So we are developing, or Jay Lund and Sari Arnell actually at the Watershed Science Center are developing a model that will hopefully help the state with, when they do their water supply forecast, how much water is now reserved for environmental flows, when should it be released, for how long. And and we work with the Water Board as well as Department of Water Resources, just really sorting out some of these biophysical factors, like, you know, what are considerations to put recharge into the ground. And there are many institutional hurdles. The water rights issue alone is not easy.
So we are 8, given the panelists and the lightning speakers, and it's a really, I've really enjoyed this session. We've heard a lot of really diverse viewpoints that are grappling with really diverse challenges. But I would emphasize also that there are many more than 8 on campus that are real experts in water. And so there's a large community here at Davis that's really concerned about grappling with water issues from lots of different directions. So we're going to wrap up the session. So I'd like to take a moment to give thanks for our speakers and our panelists. And please feel free to engage with everyone during the break and on into the future. Thank you.